Hello. Today I want to talk about places that we, or rather our descendants, might one day decide to terraform. So I'm going to go round the solar system and further to look at the possibilities and where they might actually live. I'm going to start with Mars. Mars is further from the Sun than Earth and so receives a lot less light and warmth than we do. However, it's a rocky planet with all the elements we need for our survival in its regolith. The downsides are that it's very cold, minus 63 Celsius, which is about minus 81 Fahrenheit, and it has no breathable atmosphere. In fact, it has a very thin carbon dioxide atmosphere, which is no good for anybody. It does, however, have a day length of about 40 minutes longer than our own, so that would be very familiar with days and nights of similar lengths to what we have on Earth. It doesn't, unfortunately, have a magnetic field, so unless it had a nice thick atmosphere, the colonists and people living on its surface would be vulnerable to cosmic rays and to solar radiation. The next target for terraforming is probably our own moon. It's right next door, it's very close, but it lacks an atmosphere and is therefore subject to solar and cosmic radiation. It also has very long days and nights of 14 Earth days each. Therefore, its surface gets very hot during the day and very cold at night. It also lacks certain key elements on its surface, such as carbon, hydrogen, nitrogen, and sulphur. It might seem crazy to think that we could give it an atmosphere, but Saturn's moon Titan, which is just a little bigger, has a thick 975 kilometre, that's 605 mile thick atmosphere. So it is a possibility. The next place we could consider terraforming is Venus. Venus is closer to the Sun than Earth and is considerably hotter. It has a carbon dioxide and nitrogen greenhouse atmosphere 92 times thicker than ours, with surface temperatures of 457 Celsius, that's 854 Fahrenheit. However, it's a rocky planet of very similar size to Earth, with similar gravity, of course. Another downside to Venus is that it has a very slow retrograde rotation, with days and nights lasting 60 days each. We might look at Venus and consider that it's an impossible place to terraform, but with its enormous atmosphere made up of carbon dioxide and nitrogen, we have to remember that there's an awful lot of carbon, oxygen and nitrogen there. And that might serve as a kind of storehouse, like a resource battery for our descendants that might last for 10, 50, 100,000 years if they can work out how to extract it and use it. If they can extract that atmosphere and make use of it, they could give Mars an atmosphere. It would be a good source. Nitrogen and oxygen is what they'd need. There's plenty of that on Venus. Each of these rocky planets is a potential terraforming target. However, they would all be hard to terraform, each requiring modification of its atmosphere so that it would have at least one bar at the surface. Venus is the most difficult, as we have to remove the vast quantities of carbon dioxide and nitrogen, but that would be super useful for us in our interplanetary future. The next potential target for terraforming is some of the asteroids in the asteroid belt. Of particular interest is one of these called Ceres, which is spherical, kept that way by its own gravity. It could well be given a shell beneath which a warmed and breathable atmosphere could be built. It would likely serve as a rest and recuperation centre for people engaged in mining asteroids for precious metals our descendants could use in their technology. Beyond the asteroid belts, we get to the gas and ice giant planets. When we get to Jupiter, it actually has what they call Trojans that follow or precede it in its orbit. Now, these are potential mining targets as well. So it's possible that they could be terraformed, although none of them, as far as we know, are spherical. Further out in the solar system, there are lots of moons that could be terraformed. But they're all very, very cold with very little sunlight. Water is freely available on most of them, but it's often so cold it behaves like rock and would need considerable power to warm it up. Beyond the ice and gas giant planets, there's a region called the Kuiper Belt, where a number of spherical dwarf planets reside. Like Ceres and many of the outer solar system moons, they have lots of water ice, so if they were warmed, they could be transformed into water worlds. Think floating cities beneath an all-encompassing self-repairing dome. Once we get beyond the fringes of our solar system, we have to look to other stars and exoplanets. Our closest star neighbour is Alpha Centauri, which is 4.3 light years or 270,000 astronomical units, and each astronomical unit is the distance between Earth and the Sun, so the distances are enormous. The best kind of propulsion for very long distance space travel uses a nuclear engine to heat and eject a propellant such as hydrogen or xenon, but even the best of these would take hundreds of years to get to Alpha Centauri. This means the crew would have to either hibernate or be composed of multiple generations, with each teaching the next how to run the ship. However, Alpha Centauri is much smaller than our Sun with lower gravity, which means that it may sterilize its planets with very powerful solar flares. Alpha Centauri is part of a triple system of 3 stars which orbit around each other. The other 2 are more like our Sun and may possess habitable planets. In our local region, about 7% of the stars within 33 light years of us are like our Sun, with similar luminosities and chemistries. So they may have planets our descendants may live on one day. Having the right chemistry and the right luminosity is very important for plants in particular. So if we want to grow food and survive, we probably need that. And we need to avoid solar flares from the small ones, which make up the majority. Once we are beyond our local neighbourhood of stars, we have to think about the Milky Way galaxy as a whole. Our galaxy is a giant spinning disk of about 200 billion stars, about 100,000 light years across and rotating every 250 million years. We are on what is called the outer spiral arm, about 26,000 light years from the supermassive black hole Sagittarius A in the centre, which holds the galaxy together. Some parts of our galaxy have stars with the chemistries like our Sun, but others don't. Equally, the central region close to our black hole may be subject to gamma ray bursts, which would probably sterilize any planet there. So we have to think about where we're going in the future, or where our descendants are going. So in summary, there are some places we could terraform in our interplanetary future, some in our solar system and some much further. Some are easier than others, and once we have the better rocket engines, we can think about getting to other planets in other solar systems, but we don't have that yet, and we probably won't have that for 10,000 years. I will in future videos talk about the individual bodies that we could terraform in a lot more detail. Anyway, thanks for watching. Bye.